We're looking at the second part of 1.6. I guess I should clarify. I'm going to name it 1.6b in my videos. And we're continuing our three-part definition of continuity. So the first part is, let me change colors. I want to use the same color. Is g of pi defined? Well, it sure is, because as you look at your conditions, we're looking at this statement. And we might as well actually plug in pi into this equation and figure out what that value is. So we're looking at e to the pi times tangent of 3 pi over 4. Now, I would also encourage you to actually figure out what the value is. So as you look at the unit circle, 3 pi over 4 is in the second quadrant. At the ordered pair, negative root 2 over 2, root 2 over 2. This is all stuff you should memorize, by the way. And since tangent sine over cosine, it's positive root 2 over 2 over negative root 2 over 2, and the root 2 over 2's cancel, so we're looking at e to the pi times negative 1, so we can just write negative e to the pi. Now what we also found with this statement, I'm going to highlight it with a different color, is that we also found which side of the limit. The limit as x approaches pi, well, since this is part of the right side, that's, greater than is on the right side of pi of this function, has to equal the same value, because you would do direct substitution to figure it out, and when you substitute in pi, you're gonna get the same answer. So what we have to do now is ask ourselves, does that equal the left side? Well, let's figure out the left side from the left side of this function. So as you go back to your conditional statements, which inequality is on the left side of pi? That would be less than, less, left, easy to remember. So now you're plugging in pi into these x's. So it's equal to e to the pi times cosine of pi, which again, go back to your unit circle, just change colors. Pi is a semicircle, so that's at negative 1, 0, and cosine's the x-coordinate, so it's e to the pi times negative 1. Same thing, negative e to the pi. So does the limit exist? Does the left side equal the right side? That answer is yes. The limit exists. X approaches pi of g of x is equal to negative e to the pi. We showed our work to explain it, which equals g of pi. So yes, this is continuous at x equals pi. Okay, so moving forward to some of my favorite problems, and as you get better at these, you probably will not do parts A and B. Well, the first time I was teaching this, I was kind of confused what he was asking for, but he was just basically laying the groundwork as to what needs to happen in order for this function to be continuous at x equals negative 1. And all that he's trying to get at is that the limit as x approaches negative 1 on the left side must equal the limit as x approaches negative 1 on the right side. And we can dive a little bit deeper on that. Let me change colors again. Because if we look at the left side, we're just looking at this equation. Oh, I guess I should mention, it is defined. You don't have to worry about the defined part of this. And because the question's set up this way, that you're finding values for m and k, if you read ahead to part C, it's defined everywhere. So you don't have to worry about that. And this typically shows up on a multiple choice test. Okay, so what does it mean to be x approaches negative 1 on the left side? Is you're looking at this inequality, which this is basically just saying 2 needs to equal, well, what needs to happen if we're doing negative 1 on the right side? So we're looking at this negative 1, and we can plug in negative 1 for this x. So we're looking at m times negative 1 plus k. Now we have two variables with one equation, so we don't have enough information yet in order to solve it. And that's where we get into the second part. So what two limits must be equal in order for this to be continuous at x equals 3? Well, the limit as x approaches 3 on the left side of the function must equal the limit as x approaches 3 on the right side of this function. So as I look to rewrite this equation, which will help me in part C, the left side of 3 would be this inequality. And again, you plug 3 in for this x, so we're looking at m times 3 plus k needs to equal, well, what's the right side? Well, the right side is this inequality. And again, it's defined. It may sound like I'm ignoring the defined part, but it's defined, so I don't have to worry about it. And when I plug in 3 in for x, well, there's no x to plug in 3, so we're just left with -2. So now that I've set up the problem perfectly, I just have two variables. I have two equations, and I'm looking at negative, Phil, let me write it, negative m plus k equals 2. And then my second equation, in pink here, 3m plus k must equal -2. And this is just algebra 1, which is why we make you learn algebra 1. I would probably just do these, like change the sign of all of these. This is how I would do it, because then your k's can cancel. So you're looking at 4m, because you add straight down. This is elimination, by the way. -2 and -2 is -4. And when you divide, you get m needs to equal -1. But you're not done yet, because you need to figure out what k is. Well, if you go back to that this original equation, where it was negative of -1, so 1 plus k must equal 2. That means that k must equal 1 in our equation. And you could, if you wanted to, graph out these equations. So this is probably a waste of time now at this point. But if you were to graph the piecewise function, y equals 2 for values for x that are smaller than -1. So this is the horizontal line, y equals 2 for values for x less than -1. You probably remember this from pre-calc, by the way. If you look at values for x that are greater than 3, we had -2, and again it was defined there. Well, the only way for us to have a linear equation, mx plus k, is if we had a straight line connecting those two. And you could kind of answer the question this way. Well, what's the y-intercept? The k value is the y-intercept, and that y-intercept is +1. And what's the slope, the m value? Well, it's down 1/1. So my graph here is a waste of time. You don't have to show this in calculus, but that kind of verifies that my answer was correct. And so my next problem, I'll leave A and B up to you to figure out, but I am going to show you part C, because all I do is I look at it. Okay, so in order for this to be continuous everywhere, because let's face facts, they're not going to ask you part A and part B on the AP test. They're not going to set up the equation for you. So that's why I'm leaving it for you. The only way for it to be continuous everywhere is if it's defined everywhere, and if I plug in -2 in for these x's and -2 in for this x, they have to be equal to each other. So I'm going to do some work in my head. -2 squared is 4. And -2 times 4 is -8. Plus 1 is -7. And then also set up an equation considering 3 into these equations. So plugging in 3 in for this x, so 4 times 3 is 12. Plus 1 is 13. Needs to equal, plugging in 3 for this x, that would be 3k minus m. So maybe I'll just write it this way, 3k minus m needs to equal 13. So as I'm looking to add straight down, I end up with 7k, this is elimination by the way, equals -7 plus 13 is 6. So that tells me k must equal 6/7. And then I can just go back to, I don't know, probably makes more sense to go back to this equation. let's see, 4 times 6 is 24/7 plus m is equal to, well, I want the same denominator. So 7 over 1 becomes negative 49/7. Hopefully that makes sense to you. So all I need to do now is subtract 24 over. So m will have to equal, what's that? 20 would be 69, so 73/7. I'm going to double check my math. I'll come back. And yeah, I'm fairly confident in that answer. And you could graph this out, but I don't think that would be advantageous to graph a quadratic with a linear and then connect it to another linear. It'd be very time consuming. Go ahead and work through that. Make sure that you understand, rewatch the video, and you should be ready for the day 1.6 homework.